And we're back. Well, hello there. So we're going to get into some CPU action. Why don't we just get started? So in this era driven by various compute-intensive applications like big data, AI, and IoT, well, high-performance servers obviously have to play a significant role in enterprises' digital transformation. The various important components of the server need to be properly matched to maximize their benefits for enterprises. And the CPU, the central processing unit, is one of the server's core parts, and it actually is a primary indicator of server performance. So right now in this video, we're going to take you through the server CPU basics, and this will help you better understand server CPUs in general. So the server CPU, it's also known as the server processor. Obviously, it's a vital part of the server that processes instructions and commands. Now, it's responsible for retrieving and executing instructions, processing data, and performing tasks such as serving web pages, running database queries, and executing other programming and computational commands. So this CPU, as the most important part ever of a server, has a huge contribution to servers' computing capacities. So the response speed of a server is significantly dependent on the CPU. All right, so let's dig in. Server CPUs perform data processing and storing operations, as well as input-output I/O operations, by mathematical and logical calculations. These are the four basic steps. Fetch, so the CPU grabs instructions from memory, interprets them, and directs the next operation. Decode, all instructions or commands are translated into assembly instructions. So in this particular part of the process, the server CPU decodes the assembly code into understandable binary instructions. Execute, the CPU executes instructions through calculations and technical algorithms and outputs processed data. Store. So after executing the instructions, the CPU stores output data into the memory. The performance of the server CPU determines the operation of the server, and the basic features and functions of the server CPU are influenced by the following factors. The number of server processors has a significant impact on servers' performance. Perhaps it might be obvious the more processors the server has, the faster and more efficient the server will run. But you see, multiple server processors mean that more instructions can be executed concurrently, so the CPU can then handle a more intensive workload in the same amount of time. Usually, network servers have different numbers of processors, and single processor servers and dual processor servers are relatively popular in small and large network workloads. Single processor servers are primarily used to address small to medium workloads. Dual processor servers get immense boosts in processor speed and RAM, providing better performance and stability for small and medium workloads. So server CPU socket is a connector between the CPU's processor and the motherboard. It's used for the CPU to ensure correct circuit chip insertion. The CPU stock allows for easy swapping of the server CPU and prevents damage when inserting and removing it. The number of CPU sockets in a server corresponds to the number of CPUs that can be installed. Now, typically, servers can support 1, 2, 4, 8, 16, 32 CPU sockets. Now, a one-socket server can accommodate a single processor. A four-socket server can support 4 processors running simultaneously. Now, it is widely believed that two-socket servers hold a large portion of the SMB market, while 4-socket servers are positioned in the middle and high-end markets. A server CPU core is a physical part of a CPU. It enables it to work. Multi-core processors can execute more instructions in the same amount of time. Moreover, multi-core processors enable smoother program running and require less power. Therefore, multi-core CPUs can substantially improve server performance. An Intel Xeon Scalable server processor typically has 8 to 32 cores. Additionally, there are also processors with more cores or fewer cores for different application scenarios. Although more server CPU cores represent better performance, finding the right number of CPU cores depends on your specific IT environment and workloads. A thread is a set of instructions or code for the execution of concurrent programming. So a single server CPU core can have 2 threads. If a CPU has 8 cores with 2 threads per core, that means it's going to have 16 threads to perform tasks. So multi-threading actually allows a CPU to execute multiple threads of code and run concurrent tasks of a process at the same time. So it's threads that are important to the performance of the server CPU because they can significantly affect how much a server can perform in any given amount of time. Running intensive processes, a CPU with many threads is preferred. So another thought here is the elements that I've mentioned above actually allow server CPUs to work reliably for long periods, handle multiple tasks at the same time, and boost their speed and reliability. Now, if you are considering a server, please be careful to select important components of the server. Choose the right number of server processors and CPU cores based on your IT requirements and workload. The CPU of the server is still distinguished by the instruction system of the CPU, which is usually divided into 2 categories: CISC CPU and RISC CPU, or CISC and RISC. Later on, there's a 64-bit VLIW, or Very Long Instruction Word, instruction system CPU, but we'll get to each of them in a second. CISC, so this is the abbreviation of Complex Instruction Set Computing. So it refers to the x86 in Intel CPU naming specification. It was a series of CPUs produced by Intel and its compatible CPUs, CISC, which are based on the PC or personal computer architecture. So these CISC-type CPUs are mainly Intel server CPUs and AMD server CPUs. Now, from the current server development status, the IA architecture, CISC architecture, PC server, which is characterized by small, compact, and stable, has been more widely used due to its reliable performance and low price. Now, in the field of Internet and LAN, they're used for file service, printing service, communication service, web service, email service, database service, application service, all kinds of things. Now, the biggest drawback of an IA64 microprocessor is their lack of compatibility with x86. And Intel, in order for IA64 processors to better run software from both dynasties, has on IA64 processors an x86 to IA64 decoder, which was introduced so that it could translate x86 instructions into IA64 instructions. Now, this decoder was not the most efficient decoder, nor was it the best way to run x86 code. Naturally, the best way would be to run x86 code directly on an x86 processor. So Itanium and Itanium 2 had very poor performance when running x86 applications. And it actually became the root cause of the creation of x86-64, in case you were wondering. But one final point worth noting here is that although the CPU is one of the most important factors in determining server performance, it cannot perform as well as it should without the support and cooperation of your other accessories. RISC is the abbreviation of Reduced Instruction Set Computing. Right? It's developed on the basis of CISC, which was the Complex Instruction Set Computer Instruction System, and some people have tested CISC machines to show that the frequency of various instructions is quite disparate. The most frequently used are some relatively simple instructions, which account for only 20% of the total number of instructions. But that leaves 80% of the frequency in the program. So a complex instruction system is bound to increase the complexity of the microprocessor, making the processor development time long and costly. And complex instructions require complex operations, which will inevitably reduce the speed of the computer. So for these reasons and many more, the RISC CPU was born in the 1980s, which not only streamlined the instruction system compared with CISC CPUs, but also adopted a structure called superscalar and superpipeline, which greatly increased the parallel processing capability. Parallel processing means that a server has multiple CPUs processing simultaneously. Parallel processing can greatly improve the data processing capability of the server, so department-level and enterprise-level servers should support CPU parallel processing technology. Now, the architecture is much higher performance than CPUs with CISC architecture at the same frequency, which is determined by the technical characteristics of CPUs. So RISC instruction system is more suitable for Unix, the operating system of high-grade servers, and Linux. It's also a Unix-like operating system. So we'll have a look at the main types of CPUs that use RISC instructions in mid to high-grade servers. PowerPC processors, SPARC processors, PA-RISC processors, MIPS processors, Alpha processors. Currently, the two major CPU processor instruction systems, CISC and RISC architectures, are both taking advantage of each other's strengths and weaknesses and moving toward convergence. You see, CISC borrows ideas from RISC to optimize the efficiency of the instruction system, while RISC introduces enhanced instructions to improve the efficiency of complex task processing. So therefore, there's really no need to be overly concerned about the differences between CISC and RISC. Both architectures are very well advanced and will continue to evolve over time. CISC complex instruction set is characterized by a large number of instructions. One instruction performs multiple functions. The advantage is the high efficiency of executing specific functions, such as multimedia processing. The disadvantage is the complex system design and low execution efficiency. Typical architectures include x86. RISC, the reduced instruction set, is characterized by fewer instructions, and complex tasks are completed by combining multiple lean instructions. The advantages are high execution efficiency for common tasks and low power consumption. A disadvantage is low processing efficiency for some complex tasks, such as multimedia processing. Typical architectures are ARM, Power, MIPS, Alpha, and SPARC. VLIW. So this is the abbreviation of Very Long Instruction Word. So VLIW architecture adopts advanced EPIC, which is explicit parallel instruction design. We also call this architecture IA64 architecture. EPIC processors are mainly Intel's IA64, including Intel's Anthem processor, and AMD's x86-64. So the common CPUs equipped with home or work computers are usually CISC complex instruction sets, which pursue a large and comprehensive instruction set and try to integrate various common functions into one piece. But the calling speed and hit rate are lower compared to server CPUs. The instructions of server CPUs are generally RISC, or reduced instruction set. The advantage of this design is that it's more targeted and can be optimized specifically for different needs, and it's actually more energy efficient. Cache will also determine the performance of the CPU. Due to the high computing performance requirements of server CPUs often apply the most advanced processes and technologies and are equipped with 1, 2, or even 3 caches running more powerfully. Server CPUs have used level 3 caches for a long time. Ordinary CPUs have used cache technology only in recent years. Server CPUs and ordinary CPU interfaces are often very different. Server CPU interfaces are mostly Socket 771, Socket 775, LGA 2011, LGA 1150, compared to ordinary CPU interfaces. Now, server CPUs equipped with a motherboard usually have no graphics card slot because the CPU comes with a core graphics card to meet the demand, and its CPU bus bandwidth is higher than your usual or typical home CPU. Server CPUs are designed to work stably for long periods of time and are basically designed to work continuously all year round. Server CPUs are vastly different from home CPUs in terms of stability and reliability, and servers are generally run 365 days a year, with only occasional downtime for maintenance, which requires high stability. Ordinary CPUs are designed to work continuously for 72 hours. Multiplexing is a technology used in servers. For example, a server motherboard can have multiple CPU slots at the same time, allowing multiple CPUs to be installed at the same time, which is CPU multi-channel internet technology. So this technology is only supported by server CPUs, and ordinary home computers where only one CPU can be installed on a motherboard, they are not going to support multiplexing. So I'll show you a list of the top 10 most popular server CPUs. So at the top of the list, you've got Intel Xeon E5 2678 version 3, AMD Skyline 7763, Intel Xeon E5 2680 version 2, Intel Xeon Silver 4210R, Intel Xeon Gold 5218, Intel Xeon E5 2650 version 2, Intel Xeon E5 2680 version 4, Intel Xeon Silver 4210, Intel Xeon Gold 5218R, and finally, Intel Xeon E5 2670 version 2. So there you go. We'll wrap it up about CPUs, but now you know all the differences.